Urban heat islands, characterized by significantly higher temperatures in urban areas compared to their rural counterparts, are a consequence of human modification of our landscapes and environment. The combination of factors such as concrete surfaces, limited vegetation, and high energy consumption contributes to this phenomenon. Before we delve further, some of the scientific views within this video differ from those of the UN IPCC. To learn more about the latest IPCC reports, visit their website at www.ipcc.ch. To begin, we must understand what urban heat islands, or UHIs, are. Urbanized areas tend to be warmer than their rural surroundings. This phenomenon occurs because urban environments are characterized by extensive use of concrete, asphalt, and buildings, all of which absorb and retain heat more effectively than natural landscapes such as forests, ponds, lakes, or fields. The configuration of buildings and roads also contributes to this effect by trapping heat. Additionally, the lack of vegetation in urban areas exacerbates this issue. Plants cool the environment through a process known as transpiration, where they release water vapor, thus cooling the surrounding area. The absence of sufficient plant life in cities results in greater heat retention and consequently higher temperatures. Another factor is that the plants convert sunlight into sugars through photosynthesis, and this means less heat in rural areas. This phenomenon is observable in everyday life. For instance, the next time you drive from a rural area into a city, take a look at the temperature reading on your car's thermometer and watch it rise. Or watch the temperature cool when you drive from a city to a rural area. This is a direct manifestation of the urban heat island effect. The concept of urban heat islands is not a modern discovery. It was first recognized in the 1820s by Luke Howard, an amateur meteorologist who documented the climate of London. He observed that urban areas were warmer than their rural counterparts, thereby laying the groundwork for our current understanding of UHIs. This has implications for global warming and climate change that are not widely appreciated. When scientists compile data to calculate global land temperatures, they usually use weather stations. They analyze the weather records from countries around the world, and for each station they see how the temperature is going up or down. The exact process varies for different studies, but essentially what we call global temperature is the average of all of the weather stations analyzed. The problem is that more than half of the weather stations they utilize are situated in urban areas. Also, the rural station records tend to be shorter and have more data gaps because it is harder to staff a remote station continuously for 100 years or more. Urban areas constitute only about 2 to 4% of the global land surface. This disproportionate representation can lead to what is known as urbanization bias. Urbanization bias emerges when data collection predominantly comes from thermometers or weather stations within urban areas, resulting in a distorted portrayal of global temperature trends because it is describing local urban heating. This urban warming bias can overestimate the magnitude of global warming. The IPCC, or Intergovernmental Panel on Climate Change, has emphasized in their 6th assessment report that urbanization bias makes up for less than 10% of land warming, so it can just be ignored. Scientists from the Center for Environmental Research and Earth Sciences, or CERES, have been investigating this problem for many years. They have found that the IPCC estimates are too low. The CERES team finds that urbanization bias accounts for up to 40% of land warming based on current global temperature estimates.
For the last 3 of their assessment reports, since their 4th report in 2007, the IPCC have been basically repeating the same claim, that urbanization bias is less than 10% of the land warming and that therefore doesn't need to be corrected for. But even in 2007, that claim was little more than wishful thinking. It was essentially extrapolated from a crude guess in a 1990 study published more than 30 years ago. Doing good science is hard. It's much easier to do what the IPCC has done, to dismiss the hard issues like the urban heat island. But urban heating is a serious problem that's important not just for understanding global temperatures, but also the local environments where people live.
The significance of urban heat islands is amplified by the growing urban population. According to UN estimates, since 2011, more than half of the global population resides in urban areas. Prior to 2011, the majority of people mostly lived in rural regions. This demographic shift means that an increasing number of individuals are affected by the urban heat island effect, and as cities expand, their heat-retaining characteristics intensify. The rise in urban population implies that a greater proportion of temperature data is derived from urban areas, which can influence global temperature assessments. For example, in this graph, we can compare the temperatures from the 20% most urban and 20% most rural weather stations in the United States. The data shows urban stations are warming 80% faster than the rural stations, at least in the United States. Unfortunately, outside of the United States, parts of Europe and Asia, there are very few well-maintained rural stations with temperature records lasting a century or longer. Nonetheless, scientists at Ceres have attempted to resolve this problem by compiling a rural record for the Northern Hemisphere from 1850 to present, using only rural stations or stations that have been explicitly corrected for urban biases. Their analysis shows that when you exclude urban data, the global warming is reduced by more than 30%. It also suggests an almost cyclical warming pattern. This is not what you would expect from human-caused global warming from CO2 and other greenhouse gases. Instead, it suggests that the IPCC's AR6 report may have underestimated the role of natural factors.
The IPCC report has consistently downplayed the role of natural factors, including the sun, in climate change for many decades now. The warming and cooling pattern observed in the rural temperature data can also be seen in the temperature of the ocean, as well as the behaviors of glaciers and tree rings. It is also consistent with satellite temperature record. Urban area represent most of the weather station, but only covers 2 to 4% of the global land area. There is indeed human-caused climate change in the urban data, but this is local climate change, not global. In our opinion, a better explanation for the warming and cooling patterns since the 19th century, if one excludes the urban data, is changes in the sun.
The Ceres team, in collaboration with dozens of scientists from around the world, have published several studies in peer-reviewed journals in which they show that multiple estimates of solar variability since the 19th century match remarkably well to this almost cyclical climate change phenomenon, but the IPCC's estimates of solar variability does not. Aside from the problems for calculating global warming, the urban heat island effect has major consequences for people living in cities and urban areas. And as we discovered, since 2011, that is most of the people.
Heat waves are increasing in the cities. This is completely different from global climate change and nothing to do with greenhouse gases. It's due to an increase in the urban heat island effect. These heat waves have major health implications, and it's going to get worse as the world continues to urbanize. We need to address this urban heat island problem. If governments spent even 10% on the urban heat island problem as they spend on greenhouse gas policies, it would be far more helpful for fighting the local climate change that most people are actually experiencing.
Addressing the urban heat island effect requires a multifaceted approach. One of the most effective strategies is to increase green spaces within urban areas. Urban planning that integrates more greenery can significantly reduce heat and heat waves. For instance, planting trees along streets and promoting the creation of rooftop gardens can have a substantial impact. Green spaces not only cool the environment but also enhance air quality, reduce stormwater runoff, and offer recreational areas for residents. In addition to increasing green spaces, technological solutions such as reflective roofing materials and permeable pavements can further mitigate the heat island effect. Reflective roofs reduce heat absorption by reflecting more sunlight, while permeable pavements allow water to seep through, cooling the surface. So the Ceres team has found that human-caused climate change is a serious problem, but it is not the human-caused climate change that the IPCC is focusing on. The urban heat island is a serious problem that is leading to more frequent and intense heat waves in cities where most people live. The global climate change policies that are focusing on greenhouse gases will not help this problem in any way. The urban heat island phenomenon has also biased the estimates of global warming and has led to a misunderstanding on the nature and causes of climate change. To learn more about this subject and the other work by the CERES team, please visit the CERES website at www.ceres-science.com. If you enjoyed this video, make sure to like, subscribe, and turn on notifications for upcoming content. Thanks for watching.